Western North America, 65 million years ago. The world is about to come to an end. An asteroid 6 miles wide slams into the Earth. Dust clouds block out all sunlight. Thousands of species perish. The dinosaurs never recover, and mammals inherit the Earth. It's a compelling theory, but scientists still debate what really did in the dinosaurs. Dinosaurs once flourished on every continent. Some of the best-known, like Triceratops and the T-Rex, lived during the dinosaurs' final days, a period known as the Cretaceous. When the Cretaceous period came to an end, 65 million years ago, so did the dinosaurs. For over a decade, Kirk Johnson and his team from the Denver Museum of Natural History have been combing the Badlands of North Dakota for clues to one of science's greatest mysteries.
The whole study of the extinction of the dinosaurs is complicated because here are these huge animals that lived on Earth for 150 million years. They became extinct 65 million years ago, yet it's quite hard to solve a crime that's 65 million years old. Basically, the dinosaurs disappeared 65 million years ago. Who done it?
Covering hundreds of square miles of parched terrain along the Little Missouri River, the Dakota Badlands is one of the best spots on Earth where the mystery can be investigated, where well-preserved fossils survive from the crucial time just before and just after the dinosaurs vanished.
This is it. This is the horizon which marks the extinction of the dinosaurs. Below this level, and out in here, there are dinosaur fossils. Above this level, in these rocks, there are no dinosaur fossils. So I'm actually standing on the level that marks the extinction of the dinosaurs.
What happened between the periods, the Cretaceous and the Tertiary, that could have caused the dinosaurs to vanish? One of the most compelling clues is at our feet, in a telltale layer of clay. An analysis of a sample taken in Gubbio, Italy in 1978 revealed it to be rich in an element called iridium. Normally rare in the Earth's crust, iridium is common in meteorites. Yet the Italian sample had over 30 times the normal concentration of iridium. That amount could only have come from outer space. The clay layer circles the world from New Zealand to North Dakota. In every instance, the clay contains high quantities of iridium. There was only one way so much iridium could have been spread around the world. A giant asteroid must have struck the Earth. The rock was blasted into a thick dust cloud loaded with iridium, which drifted round the world. For an asteroid to produce this much iridium dust, it must have been 6 miles wide and weighed 1 trillion tons. Though this sort of Big Bang theory was controversial, evidence began to mount that a giant asteroid crashed into the Caribbean 65 million years ago. Traces of a crater 120 miles wide were found in northern Yucatan. To leave a crater this size, the impact must have been 10,000 times more powerful than if all the nuclear weapons in the world exploded at once. What happened after the explosion? No one is sure. One theory says the explosion touched off a worldwide firestorm. One researcher did find large amounts of carbon in the iridium layer in both Denmark and New Zealand, perhaps the signature of a global holocaust. Some scientists think the explosion touched off a tidal wave a half a mile high. Others suggest the dust kicked up by the asteroid would have triggered torrents of acid rain, strong enough to kill many species of plants and animals instantly. Other scientists speculate that when the asteroid exploded, billions of tons of bedrock were pulverized, releasing vast amounts of carbon dioxide into the atmosphere. All that CO2 would trap the Earth's heat, turning the planet into a giant greenhouse. Temperatures worldwide must have soared, unless the impact caused a nuclear winter. In this scenario, dust clouds and smoke would have cut off sunlight and plunged the Earth into cold darkness. Plants would stop making oxygen. Life would slowly end.
Today, this area is Badlands. 65 million years ago, minutes before the asteroid hit, it was a pleasant forest. Imagine yourself back at the end of the Cretaceous, dinosaurs grazing on ferns and wandering through a sort of lush subtropical forest. Hours to days to perhaps months after the asteroid hit, it would have been lights out.
Since scientists disagree on the impact of the asteroid, they've turned to the fossil record for clues.
You guys know where we are? Somewhere up in here. Somewhere southeast. Yeah.
The Badlands of Montana and North Dakota have attracted fossil hunters intent on solving the mystery of dinosaur extinction. Kirk Johnson is looking for fossils too, but not of dinosaurs.
Dinosaurs are sexy, there's no question about that, but they're quite rare and they're a lot of work. Fossil leaves tell you a real different story. They give you the context. I mean, if you look at the world today, it's a green planet, and plants cover the surface of the Earth. Plants are living in environments and responding to them, so you can learn quite a bit from the world from looking at the plants. Not only that, but since plants are common on the landscape, they're common as fossils. We've done counts in modern forests and found that you get, for instance, in a single forest, there are 10 million leaves produced per acre per year. So looking at the fossil plants really gives you a window into the late Cretaceous world that is more informative than just looking at the animals.
Sometimes remnants of several plants are preserved on a single rock.
The sound. Whoa.
Leaves from a water lily and a magnolia-like plant may appear side by side. Over the last decade, Johnson has collected more than 30,000 plant fossil specimens.
And they tell us a tremendous amount about what the environment was when Tyrannosaurus rex and Triceratops wandered around in western North Dakota. You look at this leaf, for instance, it's got a smooth margin and elongate pointed tip, and that's the kind of leaf you find today in tropical rainforests, areas that have a lot of rainfall and ample temperatures. They don't get too cold in the winter, and there's always water around. It's really different than what it is here today. Now it's a desert or high plains. 66 million years ago, this was probably a broken subtropical forest. So fossil leaves are indicators of the climate in which they grew. So from looking at these fossil leaves, we can tell that this area was moist and of moderate climate. We find fossil palm leaves here, palm leaves near the Canadian border. So we're looking at a place where conditions are much warmer and much wetter than they are today.
More clues turn up under Johnson's microscope. Ancient pollen. From these, he has identified more than 100 species of plants from the late Cretaceous period. But at the end of the Cretaceous, something happened. According to Johnson, nearly 80% of all plants went extinct.
I'm fully convinced that there was a major biologic catastrophe at the end of the Cretaceous, and that catastrophe is precisely timed with physical evidence for an asteroid impact. So I think an asteroid was the culprit.
Many paleontologists, nonetheless, remain skeptical of the asteroid theory. One of the most vocal critics is maverick fossil hunter Bob Bakker.
There is a theory very popular with journalists and geophysicists that a meteorite, the giant mailed fist of God from the heavens, smacked the Earth at the end of the Cretaceous, sent out a huge dust cloud which blotted out the sun, sent down acid rain, killed all the dinosaurs. That's bunk. A meteorite may well have hit the Earth roughly when the dinosaurs went extinct. It was a cosmic backfire. The dinosaurs were already suffering pulses of extinction, already been going on for 6 million years. And if a meteorite big enough to kill dinosaurs smacked the Earth, it would exterminate all those poor tropical toads and turtles and frogs. Nothing is more delicate than a tropical turtle. It can't stand any sudden change of temperature. So if you smack the Earth today with a gigantic meteorite, as the theory suggested, and send out a huge dust cloud and chill the Earth and send down acid rain, who's going to die first? 20,000-pound dinosaur or 1-pound little pond turtle? Well, the turtle's going to die first. Well, the turtles didn't die. There's no extinction of turtles at the end of the Cretaceous. So ask not why the dinosaurs died. Better ask, why did the turtles live?
Bakker takes the long view. He looks at the entire 150 million years of dinosaurs when many different species died out long before the asteroid struck. In fact, dinosaurs appeared and vanished throughout the whole epoch, not just at the end.
It's really quite frightening. It's the same pattern again and again and again and again. What we're looking for is a serial killer, a Darwinian serial killer who strikes land and ocean every 10 or 15 or 20 million years and hits exactly the same way. And the serial killer has a extremely refined victim profile. It's always the same animals in the ecosystem who are hit. It's always the same animals who are left alone. Now that's both frightening and intriguing.
According to Bakker, the trouble began early during the Cretaceous era. The supercontinent of Pangaea began to break up, and the land masses of today began to emerge. A huge inland seaway covered North America from the Gulf of Mexico to the Arctic. The seaway slowly rolled back, and land bridges now linked continents that were previously isolated.
When shallow seas drain away, animals can walk. A dinosaur could walk from Wyoming, across Alaska to Mongolia, and vice versa. A Chinese dinosaur can walk across the Bering Land Bridge down through Canada into Wyoming. Every dinosaur that moves would be carrying 20 or 30 diseases. At the end of the Jurassic, there were land bridges everywhere. Dozens of dinosaurs were moving, carrying hundreds of diseases. There's no way you could prevent worldwide die-offs of the animals who moved.
Yet there is no evidence to prove the dinosaurs did themselves in. Harvard biologist Stephen Jay Gould favors the asteroid theory and suggests a simple reason why large animals are more vulnerable than small ones in a catastrophe.
Now, why did dinosaurs die? Well, we don't know, but if you wanted to conjecture, it's certainly plausible, and I'm just giving you a conjecture now, that the large size of dinosaurs may have been very detrimental to their existence in catastrophic times. Because if you have very large bodies, then your population size isn't very big. And the best way to get through a catastrophe is to have lots of you, because this is a chance and fortuitous event, and the more of you that are around, the better the opportunity that some of you will get through. Also, if you're very big, you tend to be quite specialized, and there literally aren't many places to hide. Whereas mammals, these tiny little creatures, probably had very large populations and did have places to hide, both figuratively and literally.
Although size alone may have doomed the dinosaurs, a new study of the fossils is revealing accessories to the crime. When the dinosaurs vanished, other kinds of animals survived. A new and far-reaching study of fossil bones by David Archibald of San Diego State University reveals some interesting patterns in what lived and what didn't.
And when we look at the pattern of extinction, it's almost a mystery at the beginning, because we see 5 groups that are drastically affected while the other groups aren't affected so much. Sharks are affected, lizards are affected, the 2 groups of dinosaurs, and marsupials. And the mystery here is, why were sharks affected, dinosaurs affected, while, for example, placental mammals, the group we belong to, was not drastically affected?
Dinosaurs died, yet turtles, frogs, and crocodiles survived. Could cold weather following the asteroid hit have caused the dinosaurs' extinction? Paleontologists have always assumed that dinosaurs could only survive in tropical climates. But paleontologist Bill Clemens of the University of California has found dinosaur bones in Alaska's far north, where the mild Cretaceous summers would have been followed by cold, dark winters.
These are some of the bones that have been collected on the north slope of Alaska. They're remains of dinosaurs, and they gave us some of the first evidence that dinosaurs could live at very high altitudes.
Today, coastal southern Alaska is cool and wet. The long summer days encourage a wealth of vegetation in the warmer days of the late Cretaceous. This type of landscape probably extended all the way up to the far north slope. Small plant-eating dinosaurs thrived. The agile Hypsilophodont had a horny beak for cropping branches and powerful hind legs, which suggests dinosaur gazelles. Bill Clemens found many of their bones in Alaska's far north.
Bones like these from the North Slope show us that dinosaurs lived in that cold, dark environment some 65 million years ago. And if you look at the specimens, there are elements from small forms, from larger forms, so that we know we had everything from hatchling dinosaurs to old adults.
The most striking discovery was a large number of bones from young animals. The old theory was that these nimble grazers migrated to Alaska for the summer and headed south again for the winter. But Clemens argues that juveniles this young wouldn't survive a 1,000-mile migration. Could they have thrived here year-round, even in winter? Recently, several other dinosaur species have been unearthed in southern Australia, which 125 million years ago had dark, freezing winters. The case for cold-adapted dinosaurs begins to add up. If the world had been plunged into cold darkness after the asteroid hit, then the cold-adapted dinosaurs should have survived, and the warm-loving turtles should have perished.
But actually, the opposite occurs. Dinosaurs become extinct, turtles and crocodiles survive, which tells us then that it wasn't extreme cold or extreme darkness that caused the extinction of these beasts.
What really killed off the dinosaurs, Clemens believes, is a gradual cooling in climate over millions of years, a slow, subtle pressure that pushed dinosaurs into oblivion. He draws an analogy to the plant world today. In the deserts, the American Southwest, cactus plants tolerate a wide range of temperatures between day and night. But in the Arizona mountains, there is an abrupt ceiling beyond which the cacti stop growing. So it was with dinosaurs, says Clemens. They could tolerate some changes in climate, but they had their limit. The asteroid theory paints a vivid picture of dinosaurs perishing in a few dark, freezing days or weeks following the mighty impact. But the fossil bone and plant research makes that picture seem too simple.
The meteorite theory is awfully popular because it makes a great magazine cover. Time magazine had this wonderful painting of a T-Rex in distress as this grand fireball came down on it. It's great art, it's great cinema, it's bunk science. It ignores the victim profile. Remember, we've got a serial killer to find, somebody who kills in the ecosystem the same way every time. And the victim profile doesn't include frogs and doesn't include pond turtles. And the meteorite theory completely ignores those unfortunate, uncomfortable facts.
It's hard to say which is more sensational, a serial killer or a giant asteroid. But one indisputable fact remains. Lots of dinosaurs are dead.
It was sort of like National Enquirer science. The asteroid killed the dinosaurs. But in the 14 years that have elapsed since the discovery of iridium in Italy, an enormous amount of data has been compiled, both about asteroids, about asteroid impacts, and about the biotic record, the record of plant and animal life across the Cretaceous-Tertiary boundary. Now, with all the recent hullabaloo about the comet striking Jupiter, we begin to realize that asteroids and comets and impacts are not uncommon things in our solar system, and there's no reason that we shouldn't expect asteroid impacts or comet impacts to be a moving force in the evolution of life on this planet.
We may never know if dinosaurs died out in epidemic waves, or if the discovery of the iridium layer is a real indication that subtle climactic pressures were at work. But one thing is certain. Without extinction, life on Earth would have taken an utterly different course, according to Stephen Jay Gould.
And it's therefore likely that we're here today because, by the luck of the draw, dinosaurs who had been dominant over mammals in ordinary times got felled in a mass extinction for which no creature could prevail or prepare. No, some scientists say that. Got killed in a mass extinction for which no creature could possibly prepare. And again, that gives the history of life its very quirky, fortuitous, chancy character. We are literally here only because of the good fortune of dinosaur extinction.
For any detective, it would make a baffling case, with several likely culprits. A slowly changing climate, a stalking epidemic, and a runaway asteroid. The trail of the clues is cold by 65 million years. What killed the dinosaurs is a case that may never be closed.